My research is leading teams to answer two main questions. The first question is, how can we slow down the rate of children getting type 1 diabetes in Australia? And the second question is, for those children living with diabetes, how can we protect them from complications later in life? So the key to the rise of childhood diabetes is our modern environment. But what we've got to find out is, what can we change in it, and when do we need to change it to try and curb this increase? What we're doing, which is unique, is going right back to pregnancy to look for the influences in the environment that are driving this increase. Over half of children with diabetes in Australia just aren't getting their diabetes control as good as it needs to be to protect them. So we still have a long way to go. Still a very difficult thing for a family to cope with.
Our research investigates the mechanisms whereby certain bacteria cause disease in humans. We're trying to develop better vaccines and novel drugs that can be used to either prevent or treat these infections. One of the principal organisms we work on is called the pneumococcus. Now, this is a bacterium which can live harmlessly in the human nose and oral cavity, and yet in a proportion of patients it's able to invade deeper tissues and cause life-threatening disease. There are some parts of the world where pneumococcal disease is responsible for something like 20% of all deaths in children under 5. I think 3 million deaths a year is a pretty good motivating factor, and that's just with pneumococcus. In spite of the achievements of antibiotics over the latter part of the 20th century, the bugs are basically getting the upper hand again.
I'm a molecular evolutionist, and what I do is use DNA that has been preserved through time to study a huge range of topics, anything where time gives us a perspective to answer important questions in science today. The thing that really motivates me when I'm doing this work is it's like a series of never-ending mysteries. There's these amazing things that have happened in the past that people don't understand, science doesn't understand, and the ability with ancient DNA is to actually go in and provide a completely new angle. We're changing, for example, the climate and the environment of the planet pretty rapidly. Just trying to guess what's going to go on, you can do through modelling and all sorts of advanced techniques. That's where the past has got huge amounts of information, particularly about environmental change. What I try and tell my students is keeping your eyes open. And by that, what I mean is not seeing the result that you were testing, is looking for the stuff that didn't work the way that you thought it would, and actually thinking that's significant. Treat everything as interesting.